In these two examples, we're going to look at eliminating the parameters so that we can determine the new rectangular equation. In this situation, we are given x equals 5 cosine t and y equals 3 sine t as our two parametric equations. And the restriction on our parameter t is that t must fall in the interval between 0 and 2 pi. Now, when we are dealing with trig in our parametric equations, we need to determine an identity that we know and can use that will help us relate these two equations. So something that we know, which is always going to be true. And in this situation, the identity we're going to use is that sine squared theta plus cosine squared theta equals 1. So let's think about a way that we can rearrange these two parametric equations so that we can plug them in. Well, first off, I can say that cosine t would be equal to x over 5, and sine t is going to equal y over 3. Now, I know I wrote my Pythagorean identity with theta, but theta is a variable, so it could just be t if we wanted it to, right? A variable is a variable as long as you know what you're talking about. So what I'm going to do is think about this Pythagorean identity. This is the same if I write it this way: sine of t squared plus cosine of t squared equals 1. Let me plug each of these in. Sine of t is y over 3, so I have y over 3 quantity squared, plus cosine of t we said is x over 5 quantity squared equals 1. Or rather, what we have here is y squared over 9 plus x squared over 25 equals 1. So what is this the graph of? This is a graph of an ellipse. Now, the larger number 5 is under x. This is a horizontally oriented ellipse. We have 5 squared in the denominator. Those are on the x-axis. And the 9 is under y, or 3 squared. So I've got 3 on my y-axis. So if I were to graph this, I would get a horizontally oriented, or I should say a horizontal major axis ellipse centered at the origin with a minor axis of 3 units out on the left and right from each center. Now, doing this in your calculator, we have a little bit that we need to talk about, and I can't pull the calculator into this program, so I have to make a separate video to show you about how to use the calculator to create some of these graphs. Let's look at one more example, though, of just turning parametric equations into a regular Cartesian or rectangular equation. In this example, we're going to do the same thing. We're going to take these two parametric equations, x equals 1 plus 2 cosine t, as well as y equals 2 plus 2 sine t. And we're going to eliminate the parameter t so that we can rewrite this in terms of just x and y. And we'll have a rectangular Cartesian equation. So as we did in that last example, we looked at the Pythagorean identity. We said, hey, we know this is always true, and this is always going to relate cosine and sine and give us a statement that is true. So since we believe this, I'm going to take each of my parametric equations and rearrange them so that they're in terms of cosine t and sine t. So for example, I would say x minus 1 over 2 is equal to cosine t, as well as y minus 2 over 2 equals sine t. So now that I know both of these, I'm going to plug them into my Pythagorean identity. Here, I have x minus 1 over 2, so that's cosine t squared, plus sine t squared, y minus 2 over 2 squared, and that will equal 1. So what is this that we have turned it into here? Well, we have x minus 1 quantity squared over 4 plus y minus 2 quantity squared over 4 equals 1. And you guys should recognize that this looks like an ellipse, but it's a very specific type of ellipse. If you look at your A and B values, they are the same. And since they're the same, that means my minor axis and my major axis will both have the same length of 2. So this is actually a circle. If I multiply by 4 on both sides, that will give me x minus 1 squared plus y minus 2 squared equals 4, or even nicer in my standard form, x minus 1 squared plus y minus 2 squared equals 2 squared. So this equation actually represents a circle of radius 2. My radius is equal to 2. And my center, HK, is at 1, 2. So this is a circle of radius 2 centered at 1, 2. And if we were to graph that, we would dot our center over here at over 1 up 2. My radius 2, that means I would move out 2 above, 2 below, 2 to the left, and 2 to the right. This is not a perfectly drawn circle, but we have a circle centered at 1, 2. Maybe that looks a little nicer. So again, I can't show you in this app that I'm using how to graph them, so I'm going to try and do that in a video which will follow this shortly. Good luck, and let me know if you have any questions.